In today's video, I'll be going over the different ways you can configure and wire your solar panels. I want to do this video to give you an idea of the different concepts of how you can make your solar panels work for you and meet the requirements that you have for your particular system. Once we go through these different configurations, you'll have a better understanding of what you'll need to do to wire your own panels and your systems up. And in the future video, I will get into specifics of how my panels are grouped and how they're configured and why I did it the way that I did it to connect it to my system. But for now, let's go ahead and get started on going over the concepts of how you configure and wire your solar panels. Let's begin by doing an overview of the different configuration types there are to connect your solar panels. The first option is to wire your solar panels in series. When you wire in series, the voltage increases but the amps stay the same. Your second option is to wire in parallel. When you wire in parallel, your amps increase and your voltage stays the same. Your third option is to wire in series and parallel. This will increase your voltage and your amps. So at the top you can see I put some information for reference as I go through these three types of configuration options. The panels I used are 260 watt panels. Their open circuit voltage is 38.3 volts and their short circuit current is 9.09 amps. To wire your panel in series, you connect the negative of one panel to the positive of the next panel. If you have more than two panels like the example given here, you would just do the same for each additional panel until you end with a positive at one end and a negative at the other. When wiring in series, the voltage increases by each panel you add to the series. So in this example of 2, you have 76.6 volts and your amps stay the same at 9.09 amps. If you were to add a third panel, your voltage would go up to 114.9 volts and your amps would still be the same at 9.09 amps, and so on. Now let's talk about wiring your panels in parallel. When you wire in parallel, the amps increase and the voltage stays the same. To wire in parallel, you would combine the negative of one panel to the negative of the other panel, and you would do the same for the positives. You can see when I wire these two panels in parallel, the voltage stays the same at 38.3 volts. But now the amps add up for each additional panel to 18.18 amps. If we were to add a third panel, our amps would go up to 27.27 amps, and so on for additional panels. This brings us to the third option, which is a series parallel combination. This allows us to increase both the voltage and the amps at the same time. In this series parallel example, you can see I have 4 solar panels. The 2 panels on the top are wired together in series, the 2 panels on the bottom are wired together in series, and those 2 series are wired together in parallel. When we configure the wiring this way, remember that when you wire in series, the voltage increases and the amps stay the same. So the top series of 2 and the bottom series of 2 end up having a 76.6 voltage, while the amps remain the same. Now remember that the amps will change when they're wired in parallel. So when we connect the top series and the bottom series together into parallel, the 9.09 amps becomes 18.18 amps. What this means is these 4 panels wired in series parallel give you a configuration of 76.6 volts and 18.18 amps. If you decided to add another panel to the top series and another panel to the bottom series, then you would have 114.9 volts because the voltage adds up in the series, and you would still continue to have 18.18 amps. So why is this important? Well, everything we went over in this video is to prepare for the next step, which is configuring how you will wire your panels to your inverters and your chargers. Depending on your system's capabilities, including how much voltage and amperage it can handle, has a direct impact on how you will need to wire your panels into the system. This is not only to be sure your system works and is safe, but it will also allow you to optimize your system for optimum operation. Additionally, it will help keep it cost effective, as higher amps generally mean thicker cables to carry those amps along with loss over distance. I hope you guys found this video helpful and informative. As always, thanks for watching, and I'll see you in the next one.